with some MCQs on escape velocity. The next question. Escape velocity from the surface of Earth is V. The escape velocity from the surface of a planet whose mass and radius both are 3 times those as that of Earth will be how much? So now in this case, let us say the escape velocity from Earth be taken as V1. Mass of Earth, let it be taken as M1. Radius of Earth be taken as R1. And escape velocity of that second planet be taken as V2. Mass of the second planet, let it be taken as M2. And the radius of the second planet, let it be R2. So taking these assumptions, now we go ahead. You know the escape velocity formula. Escape velocity is given as root of 2gm by r. So in this case, if I take the ratios of the two escapes velocities of the planet Earth and this other planet, it will become v1 upon v2 is equal to square root of 2gm1 upon r1, the whole divided by square root of 2gm2 upon r2. Cancelling 2 capital G both from the numerator and the denominator and rearranging the term. Inside the square root I get root of m1 upon m2 into reverse r2 upon r1. Now students, they have clearly mentioned for that second planet the mass is 3 times that of Earth. So m2 is 3 times m1 and the radius of that second planet is 3 times that of Earth. So R2 is 3 times R1. So we'll substitute over here in place of M2 and R2. And finally cancelling M1 M1 and R1 R1. Also cancelling 3 3. I finally get inside the square root as 1. That's nothing but equal to 1. So V1 upon V2 is equal to 1. Or I can conclude that V1 is equal to V2. Or in this case, I would suggest that if the radius and mass both are becoming 3 times, then there is no change in the escape velocity. So the escape velocity for this second planet will also be the same as that of the Earth, that is VE. And in this case, your answer is A. Let's see one more question. The ratio of escape velocity of satellite from Earth's surface to the critical velocity revolving close to the surface is how much? So ratio of escape velocity. What is escape velocity? VE is equal to root of 2gm by r. To the critical velocity close to the surface. Critical velocity root of gm upon r. Very close to the surface. If it is at a height, you know, root of gm upon r plus h. But close to the surface, it is root of gm upon r. So the ratio of these two things. So simply dividing, we get VE upon VC is equal to root of 2 gm by r upon root of gm by r. So a common term capital GM cancels, capital R cancels, and inside the root I get root 2. Or if I just rearrange this and I write down the answer, I get VE is to VC is nothing but equal to, yes, what will it become? Root 2 is to 1. And in this case, your answer will be the second option, that is root 2 is to 1. Clear?